Yes. All right. So I do think, although I still see a loading screen, we are already live. So I just trust on this.
Oh, yes, we are live.
Yes, awesome. So, hi, and welcome to this month's virtual Kotlin user group meeting. And we are bang on time. I was a bit concerned. With me again, Himanshu. Hi, Himanshu. How are you doing?
Hi, I'm doing good. How are you?
Not too bad at all. Not too bad at all. I had a couple. I had a couple of days. I had 1 week off, so this is always a good thing. So up front, the usual disclaimers and some housekeeping. So if you like us, click the thumbs up button. If you don't like us, tell us why. Also, if you haven't done yet, click the subscribe so you get the notification. And beside this, as always, I will collect all the questions you might have over the talk and will relay them to Himanshu once the talk is over. The Java Advent is happening. So if you are looking for a way to have a nice place to place your content in, get in touch with me. It's javaadvent.com. Happy to have a talk about it. We have, I think, 1 spot left, so it might be yours. And if you're interested in Java Advent, visit us in December, and you might have luck and win one of the JetBrains and IntelliJ licenses. This is all of the housekeeping from my side, and I'm really looking forward to your talk now, Himanshu. So it's all yours.
Thank you. Okay, I might start. Oh, okay. So I'm actually going to talk about more of server-driven UI in Jetpack Compose. This is a very common topic which we have been talking about since ages now, I think. Airbnb built a lot of good frameworks for it. Epoxy is there, which you can use for server-driven UI. SDUI is how, in a fancy world, we call it, right? But I'm here actually going to help you understand how and where you can use Jetpack Compose. So how would I rate this talk? Like, I'm just setting up the agenda for you first. How am I going to rate is, you would have an understanding now what server-driven UI actually means. And then I will actually help you to understand, if I'm using Jetpack Compose, how I can actually build my whole system, my screen, my UI, everything in Compose via the server. So I think I should start. So now let's talk about the agenda of this talk first. So firstly, I have this, what are server-driven UIs, which I have to definitely talk about, because without this topic, we can't even start. Like, what is server-driven UI? What is client-driven UI and something, right? Why it is important to us to know it? Like, we live in the 21st century in this internet world. We definitely need to understand the importance of it. Then we need to also understand, how do we get started with Compose? Because I know a lot of folks today joining, sorry, who have an idea about Compose, but not actually a lot about it. So I'm not going to tell you a tutorial or something, but what I'm going to do is I'm give you a good fresher, I would say, for Compose. Then I have this, how to implement a screen. So this is not actually a topic per se, but it's more like how I use a JSON response, or let's say a server response, to build a screen. Then we have the pros and the cons of this approach. When I say this, pros and cons of this approach is reason because, sorry, a lot of people actually think that when you design an approach or when you take an approach, it's always the best possible way. But hold on, I'm actually going to tell you that there is also some drawbacks of using this. So just hold on tight for the last session of it. And tips and tricks, what I generally follow out here and how do I start off it, right? That if you have to do it, how would you do it? That's bigger question now. So, okay, let me introduce myself. In the description, it might be some other company because I switched, but okay, I am Himanshu Singh. I work in Berlin in a startup called Clue. I am a Google developer expert for Android and Kotlin. And definitely you can find me at Himanshu on Twitter. That's my username. Before that, I was working based in India, working on a lot of open source. I still do open source, but I have restricted myself nowadays to more into Kotlin stuff, Compose stuff, Ktor stuff. And that's pretty much about me. Now, first, before even starting, let's understand the data-driven mechanism. What actually I mean by this is, when you talk about data-driven mechanism, in this world entirely, everything is driven by data, right? For example, you fire up your phone, you take your phone, you just open your contacts, you see all the contacts there, right? In a list, for example, that's data for you. You go to Amazon.com, you see a lot of products being listed there. Each and every item is a data here. Consider anything else. Just hold yourself for a second and think whatever app you may be, Facebook, WhatsApp, Twitter, anything, right? Everything has a data which drives the whole app. For Twitter, it's the feed data which is being pushed there. If you talk about Facebook, it's also the feed, but in WhatsApp, it's the chat data, right? Basically, it's a data-driven mechanism. Now, if I talk about in the sense of how I have to think about Android engineers, right? Because correct me if I'm wrong, but we are Android engineers. We have this concept of RecyclerView. And what do you think about RecyclerViews, right? RecyclerView is the one, I would say, component no app is complete without, right? In one way or the other, every time we definitely use RecyclerView, maybe for a list, for view page 2, something, we always use it, right? So the data-driven mechanism, what I was trying to say is, we pass on certain data. Let's say we have a server from the backend side. That backend returns a list in a JSON format. We take that JSON, we create an adapter for that. In the recycler view, we pass it on the view holders and do blah, 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 and we just display it, right? When you see this on the right-hand side of the screen, it's a very weird looking phone, but if I have to say, it has a list of items which starts with 15 and somehow it goes to 22, but it's a list, right? This actually explains you that this is a recycler view for you, and it's a list of data which is coming via JSON. That's pretty much how we used to do it. Correct me, definitely correct me if I'm wrong, but we use, let's say, JSON, Moshi, Jackson, anything to just serialize and deserialize the JSON data based on our Pojo classes, or what we call it as data classes as well, right? We use them just to render the JSON, show it in the recycler view. Now, what I'm going to suggest you is a very good topic. What if we could apply the same technique we use for data to the user interface itself, right? Give me a moment to explain. What I try to explain it to you here is, when you go to the back screen, right, this screen, here you have a card where is an image and there's a text. That image can be anything, a user avatar. It can be a user display image, a product display, and there's a name, item 18, 19, 20, whatever. So basically, how do you design this is, you get the JSON file from server, the JSON has the data. That is where we said the data-driven mechanism. So in this data, you have an image and you have this thingy called text, title, whatever you want to call it. I'll call it title, right? So an image and a title. And on the client end side, what we have is this card which we have made, which already has an image view and a text view. And in the view holder, we just set that image and the text there and there itself. But what we also do is we actually generate or tend to design this in our sequential way, correct? That's how we do it. So what I meant by this is, when you design that card, right, you just have to pass the data there, that say the image URL, or you pass what you call it as your text or title, right? But consider this, to design an interface is not just about the data. You need the padding, you need the size, you need whatnot, right? The alignment, or maybe let's say anywhere else. What if we can also pass that via JSON? This is the code, what it means like. What if we could apply the same technique we use for data to use to the end user interface itself? That's what we are going to see, that how we can use a certain JSON and display it in user face, right? So that is where SDUI how Airbnb folks call it, or for us laymen, it's server-driven UI, how we use it, right? That's what we are going to learn right now. Now, that's basically the whole gist or the agenda of this talk, right? But the bigger question is, what is a server-driven UI? I showed you the explanation or the reason I would say that we have this data-driven mechanism where, again, I'll just rephrase it. List of JSON objects in an array, which we pick it up, we throw it in a RecyclerView, and we display our UI, right? But what if we also want to design the UI based on JSON and not just drive it with the data with it, right? So consider we have a JSON, we pass it, and we design this thing, right? This is just consider it as a UI. Now, if I have to, let's not talk about the UI perspective here. What you see is a card which has a cycle image, it has a name, it has a price, and it has a rating, and with the rating number written in it. Let's say if it's a 3 rating, it says rating 3.0, right? And if the item is on sale, it says sale. So there are two ways to do it. One definitely is the data-driven mechanism where you design this UI somehow, right? Let's say in Compose, for example, or if you want to design it in the XML format, you can just design it and just populate the data from the JSON response. That's how you can do it, right? What I'm suggesting is don't do it. Just design the whole UI itself from your base, right? Pass on the list, pass on the horizontal list, pass on the items there, and just render it. Give the padding in its own value, give whatever it needs, and just do it. That is also one of the good ways how you can render a screen, recycle a screen, right? Now, that's one of the ways. What I want to say is the difference between a data-driven UI, a data-driven mechanism, or a server-driven mechanism, right? In the data, you were just populating the data in the RecyclerView, and the designs were created on the client end side. But in the server-driven UI, the server is responsible for populating the data as well as designing the data, which you can see it here. The JSON response, we do a fire up an API call and we display it, right? So let's talk about the benefits what you have while designing this whole thing, right? We'll talk about the pros and cons again after having the whole talk or just explaining you what it does. But let's once run through the benefits we see of using a server-driven UI. The first is you write a code which renders UI plus data. In RecyclerView, you just write a code which renders the data because you have already designed your UI and you're just populating there. But consider this, if you have to design it as well from the server, isn't that amazing? Just design the UI based on the JSON data, populate the data being associated with it, and just show it. Voila, users see an amazing UI. Second, consider a use case where you are doing some A/B testing. And when I say A/B testing, it basically means alpha beta testing, right? In alpha beta testing, what you basically try to do is you have, let's say, two different organizations or trial thing which you want to do. Let's say there's a task A and a task B. You want to throw it to the users and see which has a major impact or what converts user to a paying customer, correct? In that way, what I would say is maybe just use a server-driven UI. There are a lot of different applications as well, services as well, which handles your ABA. But if you want to do it on a UI end, let's say I create a payment screen, right, in which there is a button in two different places, A place and the B place. And I want to see which converts more in the payments. So what I'll do is I'll take a certain segment of users and throw them this task A, and there would be certain segment of users. I'll draw them task B. But the benefit here is I just designed the UI based on the JSON I pass from my backend. And client engineers just take that JSON and just render it to the screen, right? That's pretty much what they do. Now, this is a very bold statement to make, no frequent update to the Play Store. But generally in this reality world, it's very tough that you don't say that we are not going to update anything on the Play Store, but we'll just do it from the server. No, for sure, no. But if you use a server-driven UI mechanism where you have the UI, the data, everything just driven through server, right? You don't care what's in the app. The app only has to make an API call or a socket call, and it will just get the data or fetch the data and just render it for you. That's pretty much what you have to do, right? Correct? That's one of the benefits of using it. Now, I'm just explaining the benefits on the scale of how a company would do. So that makes you see the impact of it. Consider Amazon doing some big billion sale or some sale in the world, right? If they have an event coming out, let's say a big sale day coming out or something, consider if they build something and just push it to the app store. And if it doesn't get live on the right time, how big impact would they face, correct? But now consider that use case if they are driving everything from the server. So they have an app on the Play Store. They just change the server response on the backend side, and it goes to just show to the user, right? The screen changes, everything changes, and now the whole promo thing of that event starts. So big changes in no time. And when the sale day is over, they can just remove the JSON response and replace it with something else. And that would perfectly work fine, correct? If I'm not wrong, just correct me, but that should be a very good use case, right? And handle conflicts and issues. Why I say this is again, because consider if something you have done on your Android side and you have pushed it on the App Store. And if something goes wrong, I know you QA it, you do a regression testing, a lot of tests, but still QA are like, let's say, human, right? There are automation testings as well. But if somehow they miss something and app goes to the store, you can't just take it back. Even if you do a staged rollout, it would still be shipped to a couple of users, right? And that would create an impact for you. Now, if you do it server-drivenly, what the benefit would be is if there's a conflict, if there's an issue coming out, you just change the response and that works fine. Go back to the previous responses which we are sending, and that should work, right? So that's what I mean by handle conflicts and issues. So this was a run through or an example purpose, how I wanted to show what server-driven UI is and how like you can be benefited of using it. Now, the second is the compose part. So our talk is actually divided into the server mechanism and the compose. We gave you an example of server-driven UI. Now we'll run through the compose part of it. So as I say, hello compose, right? If I'm not wrong, that's how we do it, right? We have an annotation called composable, and we have a function. So basically, what are composables? If I have to put in a layman term, and if you have been living under the rock for ages, compose is like a UI toolkit for Android, and now it's for multi-platform as well. But sure, you can use Kotlin to design your UI. It's a declarative UI pattern where you use Kotlin to write code, just like how you can do it using HTML, CSS, and just render that function as a UI. So the easiest way how I explain someone what compose is something which converts a function as a UI thing. So it's basically a UI function if it's annotated with @composable. And whatever you write inside that function as your logic, whatever, that's a code which would be rendered, right? That's how composable is. So here I have, let's say, @composable function hello world, and inside that I'm going to write my code. If I write text hello world, it would print hello world on the screen, right? That's the power of compose, that you can literally use a Kotlin function to design a UI, right? So consider this. This is a function called say hi. It's annotated with @composable, and we have a comment, hey devs, right? So anything inside this say hi function or the block, we have like literally written anything, it would be rendered as a UI. So say hi as a function would not be rendered, but inside that block, if there's anything, it would be rendered as a UI. So that's how we use compose to design UI. Now, this is a sample which I was actually explaining you before, that let's say I have a function say hi, And if you see the difference, it's always annotated as @composable. It's a normal function, but whenever we annotate @composable to a function, it becomes a UI function. And inside that, I'm using a text component or a text composable where I'm passing the text as hello world. And if you see on the right-hand side on the screen, right, hello world is actually being printed. So that's how you use it. If I just pass hello compose there, on the right-hand side, hello compose would be there, but the function still remains the same. So what I'm trying to say here is, whatever, no matter what is inside the say hi function, it would be rendered as a UI. Not randomly. Why I'm saying this is because if I pass just log, it would not be printed there. It has to be a composable function. So our context is here, the text is also a composable function, and a composable function can only be called from another composable function. So here say hi is a composable function. That is the reason you can actually use the text composable here. But if there is no composable annotated to say hi function, you can't use this text composable here. So that's how composable works. It's a very hindsight. This is how you work with it, right? So as I said, this is a function as a UI, or you can call it UI as a function, whatever you want to do it, right? It's just one and the same thing, because in one of my talks, I actually said this, it's a function as a UI, but somebody said, no, it can be UI as a function. For sure, yes, because that's up to you what you want to move with it, right? I just want to say function as a UI. That's how I go with it. So that's the pretty much overview of what composables are. Now, let's actually deep dive into a list, right? Here on the right-hand side, I see, let's say, a shopping thingy, right? Consider this as an Amazon, for example, or whatever. In Amazon, I have added a couple of things, and I am an actual Apple fanatic. So that's the reason I chose this image. So AirPods Pro, Series 5 watch, Magic Mouse, and Lightning cable, right? So you see this is a cart. Just don't see on the code side of the left, just see on the right. Consider this whole screen as a composable function. The whole screen you have, right? Not a component. In that, if I have to break it, you see a toolbar. Toolbar again has a back arrow, a star, and more menu. And on the below part, you have the list of items in my cart, correct? That's pretty much it. Now, if you compare on the left-hand side, we just have a composable function. Then we have a composable for toolbar. Then we have a composable for the list. That's pretty much what we have, correct? Now, this composable, the first one, is actually responsible for the whole phone we have. So here it can be anything containing the items, the list, the back arrow, stars, anything. Then we have another composable, which is responsible only and only for this toolbar. So this composable function inside will have a row. That row would have this 3 buttons there. You can modify, add your modifiers. So in Compose, modifiers are like CSS for HTML. You use modifiers to design it. It's a designification thingy for Compose, but you can use modifiers to design it. And yes, you can do a lot of different operations there, like clicking, gesture control, whatever you want to, but that's how you do it, right? So this toolbar here represents the toolbar we have on the top. Then we have this another composable, right? Another composable, the whole list would represent my cart and the items we have in the list. Because consider this has to be a list. So whenever we scroll it, then my cart has to also hide it out. That's what this composable means. Then we have this list header composable, which represents my cart. So in this composable, there would be only another one composable called text, which would have a text of my cart. It can be from server, it can be static, whatever you want to prefer. Then the second one, or the last one I would say, is the composable, which has the items of the list, right? List items, I would say, which contains your AirPods Pro, Watch 5, Mouse 2, and Lightning cable. So that's how I would break the composables into. There are a couple of more ways to do it. Like let's say in the composable, the previous ones, right? This one. In this, you don't have to use two different composables. You can use one composable to render the title or the header and do it. But for just making it more easy, I kept it two different composables. One is for the header and one is for the items. So that's how you structure your composables when you have to see a screen, right? Now, you actually saw this whole code, right? This code give you an idea of the screen, how it looks like. Now, let's actually break it down in a very minute way of each item and then the whole list. So I'm picking this magic mouse thing and I have to use it, or I have to design it via an JSON response, right? So I'm using this, for example. Here, if you see on the left-hand side, it's a JSON, which uses vertical padding. It has a vertical padding, right? It has a horizontal padding. If you see, there's a view type called list items, and it has a key called data. Now the data has image URL. I've just passed on a dummy values here for sure, but I didn't want to change it because I just wanted you guys to understand, right? Then we have title, we have a price, and then we have an ID of that item. So consider we have 4 items right now. What consider, but it has 4 items, right? Apple AirPods, Apple Watch 5, Magic Mouse 2, and Lightning cable. So now this one JSON block, which we have from vertical padding to ID, represents one item in the list. It can have multiple more items like this. I'm just saying, but this is a representation of one of it, right? Now, how would you do it, right? So consider this. How would you approach the problem? So this whole thing, this magic mouse item, we have a view type, if you see on the left, is called list item. And we have one more UI in the screen, compose like the toolbar. Let's say, call it as a toolbar, right? Then we have another on the bottom button. Then we have another of a total component. It can be a text component for sure, but I'm just saying it can be n number of components, right? For now, I'm picking 2 of them. Here, we have a list item, the one which is highlighted, the magic mouse 2 one, and then we have a toolbar one on the top of it, right? The top within 3 buttons, we have view type. So I'm just keeping the number of view types we can have on the toolbar. Now we'll map this with the ones we get in the response. Here, the list item was the one, so we'll map it with the list item in this class, view type, right? That's how we'll do it. Now, if you go back to this UI somehow, what you'll find is we have 4 keys here. We have the paddings, 2 padding, vertical and horizontal. Then we have view type, and then we have the data. So 4 types. Data has multiple different set of values of its own, but what we have here is we have 4 type of data, correct? Or the keys. So in that way, I'll actually consider a data class for it. So how do you do for a normal API call? In an API call, what you do is you map the keys, vertical padding, horizontal padding, view type, and the data, right? That's how pretty much you do it for an API call. Here as well, I'm mapping this JSON response, this vertical padding, horizontal padding, view type, data type, right? This 4 as this data class. So this data class is actually a view element. I'm naming it as view element. Here you can see we have a vertical padding, and I'm mapping that with the key of vertical padding using serialized name. So this is pretty clear that we are using JSON for it. Then we have horizontal padding. We have also annotated it with horizontal padding. We have view type, which we are passing item type and toolbar, whatever. And then we have data. Now, if you see, the data is here, a view element data, which is another data class we'll see. But now we have mapped 4 types of keys here. These 4, vertical padding, horizontal padding, view type, and data. And we have it. Now, this view element data here, what we have is actually a representation of the data we have in this card, right? The Magic Mouse card, or let's say the Watch Series 5 card. We have all the data is there, and the AirPods data and the lightning cable data, and we have it in the view element data. So how would that look like for you? You have already seen that, right? In the JSON, image, title, price, ID. But how would it look in the response in a data class? So now view element data looks like this, right? The view type. What is the view type of it, right? Then we have an image URL. Then we have title, price, and ID. So view type can be, again, anything, whatever you want to, because this view element data is the part of this magic mouse. So this can actually be a generic data class where in place of passing view element data, we can pass, let's say, a T or anything, whatever variable naming you want to, and just pass on this view element data, whatever you want to, whenever you want to use this data class, right? So here we have image URL for the mouse thing. We have a title, Magic Mouse 2. We have a price 99 and an ID, whatever you want to again. So this is that element data, right? So we understood, this is pretty basic stuff, I would say, that how we can use JSON and map it to a data class right now. But with data classes, this was pretty normal, right? How we do it for API calls. Now, how we spoke about function as a UI, which is composed, right? Now we'll use that function to render it, right? Now, if I have to go to, just see this. This is a render list item, which takes a view element. Now, what's a view element? This is a view element which we had, the data class. The response of this JSON object is this. This is the data class we have for that JSON block. And you use this list item. So we created a composable called render list item. We passed the view item here. Now, if you see here correctly, we have a row because this whole card, Magic Mouse 2, is a row. Where we use this row, we pass the paddings there, view element, horizontal padding, vertical padding. How you can see that, right? We have done it. Then we pass an image where we again get that image from the elements. We have a column where we pass the title, text, whatever, right? You can have multiple different elements. I'm just, for the sake of this talk, I've kept it small. Now let's break this down in individual components, right? Here, the view element actually represents the specific card. The specific card we have of Magic Mouse 2, the highlighted one, right? Then this view element, which will have the data for padding, it will have data for the title and data, vertical padding and horizontal padding, it would be contained here. Then we have this row. Now, generally, the row is basically a very common English word for row, which has all the data in a sequence in the horizontal way, right? There are two stuff in Compose. One is row and another is column. So when you talk about column, it's one after the another, one by one in this sequence. And when you talk about row, it's a thing in the vertical manner, in the horizontal manner, like how we have it here. So this is a row which contains image, a column, and the price, right? So here you can see we have a modifier. And as I gave you an earlier hint, that modifier is nothing but a CSS. So if you see here, we have actually filled the max width. Like when I say this, fill max width basically means match parent. Then we have added padding. So in padding, there is horizontal and there is vertical. Now this horizontal and vertical padding, we're actually getting from the JSON itself. So we don't have to set it manually. And let's say if someday we want to close in it enough, we can just change the value. Just consider the power of this now. For now, what we were doing is, I'll go back to my slides again. You can see the vertical padding, we have added 12, and the horizontal padding we have added is 16, correct? Someday in future, consider some designer comes up and tells you, okay, 12 is not looking good. Maybe we should try 20, right? As general engineers, what we'll do is we'll just change it and we'll wait for it. That, okay, someday we'll do it. But now, since we did it in a server-driven UI system mechanism here, right? We can change it just 20 and we can see it in the real time how it looks for the people, right? It's again, how you see it as an alpha beta testing, that one user will see a 12, another user will see 20. That's how we can do it. So we are using that horizontal padding here. And the rest of the stuff is just data we have. view element, data, image URL, and then the magic mouse 2 and apple are basically a column, one after another, like how you see for the row, it is on the left and right hand side, right? So here we use this image composable again. We pass the URL, which we have as an image URL in that data class, right? We pass the image for a URL here. That's it. Second, we have this column, which presents the magic mouse 2 and the brand of it, Apple. That's how we use the column for text and title, view element, data title and stuff, right? And lastly, we have the price, $99.99. So if you see now, if I go back again, you see inside this row, the whole block, the card is actually a list item. Now inside that we have the max width, like the match parent. Inside that we pass image, column, and the text. And we display this here because we are getting that data from the server. We have the padding values from the server. Now, in short, it's a server rendered list item with the data and the UI, right? That's how you do it. Now, this comes the second part. If you see this thing, we have a list item here called render list item, right? But nextly, you have a list because for sure, there can be a number of items. Now we are talking only about Magic Mouse 2. But if you see in the design, it doesn't just only have that. It has AirPods Pro, Series 5, Mouse 2, and Lightning cable. We have to also talk about that. So now for that, we have a list again. It also takes a view element, right? Because there would be n number of items in the list, and among that, individual also would be an item, right? That's what I'm trying to say, that this whole render list is a list, view element, and inside that, there will be n number of view elements again. So the render list is actually the whole parent of view element. And now here you see we have lazy column. So lazy column is nothing but a RecyclerView Jetpack Compose. A very basic way of explaining it, what it is, right? Now, there are two blocks to it. There's one item and there is items. When you say about items, it basically takes one composable and it does it for you. So item is like one container where you can pass only one composable and it will render that item in the list, which would be scrollable. So what we want to do here is one item would be my card, correct? So that is the item we have passed. We'll just use text, view element, data, title, whatever we want to, whatever we got. And then again, you see there's another items and not item. It's a plural thing. It takes the list with whatever we have. Let's say we get that list from an API call, correct? We use that list and in the item, we just call it the render list item. So to understand items, what it is, it's considered this as a for each, that list dot for each, and individual item, whatever we get, we just use this render list item to render that. That's pretty much how we do it. And this lazy column would now start scrolling it in a very good way. Like this whole list would be prepared. Now, the only thing which would not be there is total checkout and the toolbar. But with my cart and the 4 items, this is pretty much it. So now if you have an API call, you just call it and just start using it. That's how render list would work, right? But we talked about how we can use view elements, how we talked about how we can take out the data from a JSON, but we still need to render it right on the screen, because if it's not rendered, no user can see it. That's the next step. So now what you do is in your activity, let's say, we just have an element, the view element, right? We do an API call. Let's say we get it from the view model, somewhere. And you use the set content and just use render list. The function which we created here is a composable function. Use this, the render list, and pass on the element there. Now, since you're passing that element from an API call, and whenever the app opens, right, the onCreate function would be called because the activity is being created. And when you create it, the element will get that data from the view model, and then it will pass it on the content. So you'll have the data, right? That's how you can use render list to render that data. It will have the padding values for you, which you're getting from the API. And that's pretty much how you render the list, right? That's how to do it. But I explained you what SDUI or the server-driven UI is, and I also explained how you can use that JSON block which you're getting from the server, use it as a data class, and then pretty much break it down and render it on your screen. But what exactly is a server-driven UI in Compose? Like when we talk about Compose, we talk highly about it, we praise about it. But what exactly is it, right? That's the next question we have. So I call Compose server-driven UI nothing as a component-driven UI, because no matter what you want to do it, right, you still need to have the component for it. So even if you ship your application, right, even if you ship your application, let's say from a server or anything, just push it to the app store, the app should at least have that n number of components for a text, let's say for a list, or let's say for image, whatever components, it should have their own components where you just pass on that values from the JSON, like the data classes, data, text, title, padding, whatever values you want to, just should have it, and you pass it on the components, right? That's something you should have. And in Compose, you can individually create your separate components and just pass on that data. Let's say view element, you pass it to the composable and just populate that components, right? That's how you do it. So in Compose, I don't call it as a server-driven UI, I call it as a component-driven UI. Now, if I do an API call, let's say how you were seeing it, we are calling element in the onCreate. So we do an API call. From that, we use a renderer with a view model, whatever, right? Because this whole view model thing will go to the API, to the repository, get some data from you, associate it to a mutable state or live data, state flow and live data. It will give it to the composable to render it. Now, here, a composable can render it for you, or a component can render it for you, right? Because what we talked previously was a component-driven UI. So now when you do an API call, view model does the error handling and whatever you want to do it. But when you get that specific data class from the retrofit thingy and you get that data class, you have to render it now. So that render process actually happens into a composable, or which we call as a component. So this is the three basic building blocks which you see: API call, renderer, and the components. But if you also have to do a crazy level of stuff, you have to also manage state into it, that there is a state to it and you can just pick it up, right? Because let's say if you're typing something, you're creating a form, you need to manage it with the state. That's how you do it. Now, we are into the last part of it. So we'll talk about the pros and the cons of using the server-driven UI using Compose, right? Again, no frequent update to the Play Store. I'm just repeating a couple of stuff which we talked about in the benefits. But now if you master this thing, this is 2021, and you need to know how this works, right? Consider this as an example, what I'm explaining you. You see Firebase promotion thing, right? In-app banners and stuff. How does they do it? They have given you a console access. You feed some data to it. And at that point, it actually goes around and shows you a pop-up in the phone. How do they do it? That's actually a server-driven UI. Now, associate that with Jetpack Compose. Create a component like that, which takes certain padding, takes an image, takes a deep link to be clicked, which you pass on from your, Firebase console or your own console, right? And just pass that data on that console for yourself. And you would see that user has actually seen that pop-up now. So you don't have to update anything and just use your server to build your dialogues, or maybe do a promotional event, whatever, right? Second, control anything from your backend. Now, the backend becomes your whole power guard, or the guard which can actually help you do stuff, right? I change the value of a padding, the screen changes, I change this and this changes, right? This is nothing but just like web. in web, you change the CSS and you would see drastic things happening. This is what will happen if you do it with the server-driven UI on the client end side, right? What do you think this third statement even means? Less hassle on the client end side, because what I try to say is now you don't have to use or maybe manage a number of things on the client end side. The backend is taking control. It steps ahead for you, right? You have the granularity now that I can change from one source, the backend, either the data or the UI, and you have that control to change whatever you want from the backend. That's the pros of it, right? And as I said again, push some event coming on Amazon on some day, and if something doesn't work at all, you can just roll back to the previous JSON file which you have and just fix the issue and just see what's not working on the JSON, the new ones, fix it and just replace it with the new one, right? That's what I say, fix issues on the fly, right? But with every good thing, there are precautions which we need to take. There are pros and cons of it. Now let's talk about the cons. Too much of component building. See, as much as how it sounds fancy, server-driven UI, for every basic thing, whatever you have to do on your app, you have to build components for it. A text component, a banner component, how we talked about the in-app banner of Firebase, you still need to build a component for it, right? Because basically you'll pass on the data. Or you create a maybe, let's say, a renderer or something, but still you need to have a bare bones structures where you populate the values to it, because no matter what JSON gives you, JSON will still give you a value. It would never give you the whole composable in itself, or it might be, but never seen it, never experimented it. So it will always give you a value, and you need something on the client to process that value. So for sure, you have to build a number of components. Then basically, let's say you change something, you still display a new page. For example, you have this value in the cart, you change it, the API changes. And since the API has changed, now you have to do a redo of that API call and do a re-render of that screen. So something changes, basically a state of a page changes, a new data generates, right? A new page generates based on that new data. Third, for now, let's say if you are using an API call for entering data on your phone, on your app, you might be using if 10 times. If you start using that API calls for rendering UI as well, I don't have to say how much it would increase. That might increase the cost of your backend system as well. Now that's something which you need to figure out what you want to do, but that's pretty much what you want to, like, increments when you using a server-driven UI. It can open a socket, something, right? Now, the last segment of this part is, it's a tips and tricks what you want to have follow, right? First, whenever you use a component, let's say a text component, I have a title component, for example. A title component can be used multiple places. It can be in a list, it can be in a calendar component, it can be anywhere, but the title has to be seen. So make small components, try to use as much as small and reusable components so that it can be used at multiple places and multiple different times, and whenever you want to invoke it, so that you don't have to redo and make 3 different components for one basic thing, right? Then have a consistency in component building, because let's say if you build something which is very good, and if you don't have that same consistency somewhere else, but the backend folks, when they design the API, it would always have that same consistency. It will always give you a view element data class always from the backend. It would not say, okay, you have not written this component in a very good manner, maybe I will change my response for this. No, it would have a consistency in the JSON responses. You need to make sure that the consistency in component building in Compose is also there, right? Now, manage state effectively to reduce network interaction. Why I say this is because, remember, right, when we talked about that, we use this whole thing and we change something, a new page would generate, a new API call would be there. So now the state management becomes a very good helping hand for us. Like, let's say we manage the state effectively to reduce the network reactions. So now if you start managing state and in a very proficient way, let's say if you were using 10 times an API call for the same screen, now you might actually turn out to be 6. 4 seems to be a very smaller number, but consider if being used by million of people, let's say Amazon. If 1 million people are using at one time, then 4 million people reduce the network interaction. That saves a lot of cost for you, right? And when you start designing something for this, just don't jump into building components. Sit with your backend engineers, finalize a contract, and then experiment and play with it. See what improves your rendering time, what improves your design framework, what sets with your design system, and then select the best contract possible from the backend side. Because now, even though backend is driving the UI, you are still responsible for the client, right? And that's pretty much it. If you have any questions, I am open to it. But yeah, thank you so much.
Awesome. And we already have the first couple of questions in. So the first one comes from Ivan or Ivan. How do we change code so we can move the image of the product from left to right?
Okay. So when I spoke about, just a second, I'll just go back to my screen so that. Is it still shared, right? You can see it.
Nope. Nope.
Oh, shit. Sorry.
No, no worries.
Now is it?
Now it's shared again.
Perfect. So what, if I'm understanding it correctly, you mean that if I have to share it from the left side of the mouse to the right, right? So if I go back to my JSON response, if you remember, just let me go there as well. There you go. So I have passed the vertical and the horizontal padding there. Let's say in the data, which we have for the image URL. Now the image URL in the data when itself would be a view element where it would have a position, let's say left of it or right of it. Let's say the constraints, how you use it, right? It's a basic sample of a JSON. You can design your sample, as I mentioned, based on what you want. So what I mean here is now in the image URL will itself have a data, which will have the reference to the position it wants to, let's say, for example, left, and on the right, it might have the magic mouse ID. So now when you design it, you can pass on that references to the different IDs of the column of magic mouse 2 and something and use it. Now, if you change, let's say the ID of that image URL from magic mouse to the pricing thing, right? Let's say pricing ID. Then the position would directly change because now it is not referencing from the magic mouse 2 keyboard, because now it's just how you say it in the relative layout thing or the constraint things, however you want to do it. It's just that how you design the contract for your design.
Yeah. All right. And then Julian A has 2 questions. Let's start with the first one. It seems that server-driven UI is also possible using the pre-compose view system. So what unique advantages does Compose add to server-driven UI beyond what's already possible?
Sure. Okay. Definitely, yes. Server-driven UI is a very older concept, even pre-Compose days. But I would say the biggest benefit which I see is when you start building something, right, from the view system, what you do is you now manage 2 different set of things, XML and the Kotlin or the Java part of it. Now with the Compose thing, you start just use one thing, Kotlin. You build data up with it, you pass UI with it, you do only one stuff and just manage everything in the one singular block and not manage 2 different stuffs. So managing that n number of XMLs now reduces, but you also manage components here. So it's just one thing, but using one thing for everything.
Okay. The second one was also, why has there been an increase in interest in server-driven UI since Compose became available?
Yeah, that's one of the biggest reasons. Like people were super excited about Compose is it gives you that granularity of how you want to design it. Consider it. For example, I'll explain it to you via composable items. So maybe I might have somewhere. For example, this thing, right? This is a UI which you have built using Compose. Now you have it. Let's say view element has the horizontal padding and the vertical padding here. What you can see it in the row. We are passing it here, right? But when you go back to the stuff where view elements were there, you have to use layout inflator or something just to add on a padding. But now see the ease of using the whole padding or the view elements thing here in the row, and you will just see how it works. So that's one of the increments, I would say, because the ease of stuff has become very amazing right now, I would say.
All right. And there was a follow-up. So sorry, David, your question comes next. A follow-up from Julian. What's being shown is limited because its effects are limited to UI. What about driving logic from the server as well? Briefly, how might that be done?
Oh, yes. Okay. You can drive your logic as well. So consider this. Now, I'll just go with a very basic example, right? A premium and a freemium service, for example. Now, consider this literal UI where you have 4 items: pods, series 5, mouse, and lightning cable. Now, let's say you're a free user. A free user can only add 2 items to it. But if you're a paid user, you can use 4 items to it. So what I can do is I can just put on a composable here somewhere. I can just have a if condition or have a logic check. Let's say that if the user is premium or is a paid customer, show all of that, or if not, then show a banner saying that you need to purchase it. So you can drive your logic as a part of your JSON, how we were doing it. So logic didn't change here. So what I'm trying to say is this, let's say element data, or let's say this view element, right? This can have your logic, how we had it initially, that if the price is something, or if this is something, you can use your when statements or if conditions anywhere you want to. So that would drive your logic there.
Okay. And now, as promised, David, I don't even try to pronounce your last name, sorry. What about animations?
Compose has an inbuilt amazing set of toolings for animations, for sure, yes. You can pass different types of animations. So like, for example, you have a visibility animation that you want to animate something or show in the screen that, let's say, visible. If your item is visible, you show a certain set of animations going around. You can control that with the view elements. Let's say if I have a key here, val is animated true, then I just check that if animated true is true, then I'll just show an animation, or else I'll just pass the false and it would not animate itself. So it's just that how you want to drive it. So the whole logic behind server-driven UI is how you communicate efficiently with your JSON responses from the backend to what you have on the client.
All right. So I took the liberty to answer one follow-up from Ivan, and I hope you don't mind.
Oh, no.
He asked that sounds like you need to hand code all the flexibility you foresee in the JSON contract and the code that handles component initialization. I took the liberty to say correct, because this essentially, it's a contract. Yeah. We as the developers define. There are no other questions yet, so feel free, if you have any, still drop them into the chat. I do have a question as well. So is there a best practice on verifying that you are actually talking to the correct API? Because I think you can do some harm depending on how flexible you make the UI via JSON fields. So is there anything you can verify that you're actually talking to the correct backend, so there's no one trying to inject data in between, or is this something I have to code manually myself?
I didn't get correct backend thing, because that's an API endpoint which you will integrate. So what
but essentially, if you have a large application, it's the easiest of doing is like provide a free hotspot and people connect to it, and with this, you have the control over DNS. So your my awesome remote app.com points to the attacker's server, not to yours. So is there anything?
Sure about this? Never.
Okay, no, fine.
Yeah, I've never been through it, but it's actually a good question. I'll go for it.
Well, because it's there are a couple of ways to approach this, and I was wondering if you used something to do this before. If not, it's fine. It's really just curiosity.
No, I've never seen a best practice per se for this, but I'm not sure. I've never been through this, so maybe I'll see it. This is a good question. Thank you.
Yeah, no worries, no worries. Happy to have a chat about this afterwards. So,
Sure.
right. So it looks like we either answered all questions and no one has any further questions, or no one is daring to ask anything. As always, it was a pleasure to have you on.
Yep. It was same for me, the second time here.
Awesome. Right. So, unless you have anything to add.
Thank you so much for having me. That's the only thing.
I was not fishing for this, but you're more than welcome. And yeah, so it was great. And for all the visitors, stay with us. And we will have a next session, I hope, in November. And there will be things coming along. You can follow on Meetup.
I have one more thing to say.
Yeah, go for it.
Please do subscribe this channel, because frankly, I came to know about this as a viewer because we do a lot of good sessions here. Definitely subscribe for it.
And if you're interested, feel free to get in touch. We are on the Kotlin Slack. There is, if you are not already on there, do not hesitate to subscribe. There is a link to subscription. Yeah, so you can get an invitation via the link you find at the bottom of the description to this video and to all the other videos. And hang on, there is another question coming in. Okay. Are you still up for a question?
Sure, yeah.
Okay, here we go. How to handle different screen size issues.
Okay, different screen size issues. You have to always use this padding thing or a range of stuff. Let's say when you pass a padding, you can pass multiple different values. So I'll give you my example. We had this data class for padding itself, where we had 3 different sets of screens, one for this, one for this, and one for this. Based on what screen we have, we derived that logic, that what current phone is it, and based on that, we used to pick that value. So that value was picking up based on what screen we were on, and that you can get it from compose of device or something. I don't remember, but it's something with local. I don't remember that word, but yeah.
All right. So I hope this answers the question. David says thanks. So it looks like we answered the question.
And if you have any questions, reach out to me on Kotlin Slack or Twitter, wherever you prefer to. Yeah.
Yeah, good thing. And yeah, so if you are interested in giving a talk, you're more than welcome. We help you out as much as we can. No worries, we won't bite. And it's a good start into your talker career. Right. Yeah. So with this, thank you all. Thanks, Himanshu. And see you all next month then. Cheers. Bye-bye.
So much.